Good morning, grade 8s, and welcome to lesson number 7. So we are going to bounce back quickly to page 106 because I know you went on further in your lesson yesterday. So I'm taking you for one more week, just one more week, and then teacher Almay will be taking you from next week. So we're going to quickly go back to expansion and contraction of materials. Don't worry, there's just a few pages. It's things that you come across every day in life. Metal pipes and balloons and tires and your cars. So expansion and contraction of materials. Remember that particles have energy and they vibrate in place in a solid, so they're vibrating in place. In liquid, they move past each other, but they're still moving, there's still energy. And in a gas, they're very free moving, they hardly see each other almost. So this tells us that there's always energy in a material, in its particles. So now, if we add energy to those particles, we learned in our previous sections that they gain energy. We've added it, they gain it makes sense, and they start moving quicker. But this breaks the connection or attraction, forces of attraction between them. So the more energy you put, the more they move, and they start breaking that force of attraction that keeps them in the structure that they're in. So now these particles are more energized. Like we learned, they change state, but they can also make the material expand or contract. So when a material expands, it grows in size. And when a material contracts, it becomes smaller. So remember that particles with more energy, they move quicker, their forces of attraction break down, and they can, depending on what substance it is, contract or expand. So now expansion and contraction in real life. So this doesn't happen in South Africa, besides in maybe the very cold parts, but it happens in mainly the colder countries. So pipes, water pipes, will burst because the water inside them will freeze. And when water freezes, unlike a lot of materials, it actually expands. So now it pushes against these pipes. It has nowhere to go, so it's pushing against these pipes, and they can burst, as you can see in the photo. Now this isn't good because if there's a hole in the pipe, the water won't be going to the house, and that's what we need. So to protect these pipes, we do an insulating material to line it with foam. So there's always a way to fix it, but remember, if they ask you for an example in real life, you use water in your metal pipes and it expands and puts pressure on the pipes, and they can't take it anymore and they just burst, and then they're useless. Okay, so we protect them with foam. Then on page 110, we are doing pressure. So now with pressure, we're going to work with gas pressure, which in the book it says, force created by gas particles hitting the walls of their container. So we're going to imagine a balloon. So this is our balloon. Gas particles always expand outwards. They always want to move outwards. They always want to be free and get away. So they're hitting the sides of this balloon surface, well, on the inside. And they just want to get out. So they're hitting and hitting and hitting. So this is causing gas pressure, because if they're hitting outwards, that means they are keeping the balloon in a structure of being blown up, not when we start off with the balloon, when it's all floppy, like the book says. So this is called gas pressure. The more particles that collide with the walls of a certain amount of the walls in a certain amount of time, the greater the pressure. So the more particles hitting the walls, the greater the pressure. So gases exert their energy outwards, their pressure outwards, and this is why when we have a flat tire, we fill it up with gas pressure, so our bouncing particles that are hitting against the walls, to make it a fully pumped tire again. So the two best examples are our car tire and our balloon. So when there are not enough gas particles hitting the sides of these, then what happens? We have a flat tire and a floppy balloon, because there's not enough gas particles hitting it to keep that gas pressure up, to keep it going, which means ultimately there is no gas pressure, and it forms the material to become deflated. So you can't use the word deflated for all materials, but that's a way to think about it. Gas makes it all big and puffy, like, yeah, strong, and then you take out the gas particles and it fades down because there's no gas pressure to keep it going. So, and to keep it inflated. So I will send the activity with the video, and you've done a bit of chemical reactions now, which we are flying through the work, which is amazing. And Teacher Almay will see you next week, and you guys better work hard and send me the activities, and I'll send you the memos when you're done and I can see the work, and I'll chat to you at our Skype session. Thank you. Bye.